Bill Nye, the world-renowned science communicator affectionately known as the Science Guy, has spent decades igniting our curiosity about how the world and the universe works. From atoms to galaxies, from chemistry to astrophysics, Bill Nye has invited millions to embrace science not just as knowledge, but as a powerful lens through which we can understand existence itself. Now, he returns to our screens with commentary on some of the most profound images humanity has ever captured, images from the James Webb Space Telescope, JWST, that peer deeper into time and space than any before it. These new observations from JWST don't just offer beautiful pictures, they're rewriting our understanding of the cosmos. According to Nye, they challenge old theories, inspire new ones, and may even hint at possibilities once confined to science fiction. What makes these images so extraordinary? Why do they matter so deeply? And how have they reshaped our grasp of the universe's origins, structure, and fate? Launched on December 25, 2021, aboard an Ariane 5 rocket from French Guiana, the James Webb Space Telescope is NASA's most ambitious and complex observatory to date. Unlike the Hubble Space Telescope, which observes mostly invisible and ultraviolet light, Webb sees in infrared wavelengths, which allows it to peer through cosmic dust and detect objects billions of light-years away. After months of delicate unfolding, calibration, and alignment, JWST began full scientific operations in mid-2022. What it saw stunned scientists, and even Bill Nye. One of Webb's first revelations came in the form of ancient galaxies that likely formed only 150 million years after the Big Bang, pushing back the timeline of galaxy formation far beyond what Hubble could observe. Webb's powerful instruments are not just photographing these galaxies, they're analyzing their light to determine age, distance, and composition with unprecedented accuracy. According to Nye, this is a monumental leap in our exploration of space. The telescope is, in a very real sense, a time machine. When it captures light that has traveled for over 13 billion years, it's showing us what the universe looked like when it was only a few 100 million years old, a cosmic toddler. Some of these galaxies appeared surprisingly well-formed and structured, defying previous theories that such maturity would take billions of years. This forces astrophysicists to rethink models of early cosmic evolution. But the telescope isn't just revealing galaxies. It's capturing the birth of stars, as seen in the Pillars of Creation, located in the Eagle Nebula, a region already famous from Hubble's iconic images. While Hubble showed the towering columns of gas and dust in visible light, JWST peered through the haze using infrared imaging, exposing dozens of protostars. These are infant stars in the earliest stages of formation, embedded in dense clouds of dust. They appear in Webb's images as glowing red dots, each a sun in the making. Bill Nye explains that these young stars are still accumulating mass. They're not yet fusing hydrogen in their cores, but they will be. Once enough material collapses inward, the pressure and heat will cause nuclear fusion to begin, and the protostar will erupt into life. At that moment, its core will heat to over 2 million degrees Celsius, becoming a fully functioning star. The variety of colors in Webb's images correspond to different infrared wavelengths, revealing heat, dust density, and molecular compositions, all data points crucial for understanding star birth and stellar evolution. Webb's exploration extends beyond our galaxy as well. One of its early achievements was capturing the first direct image of an exoplanet. The planet, known as HIP 65426b, had been identified in 2017 but had never been directly observed. It is a gas giant roughly 12 times the size of Jupiter, orbiting its star at a distance 100 times that of Earth from the Sun. Its vast separation from the host star and intense infrared brightness made it an ideal candidate for Webb's instruments. Using coronagraphs to block the light of the host star, JWST observed HIP 65426b in multiple infrared wavelengths. This breakthrough opens the door for more direct exoplanet imaging, especially for massive gas giants. Most exoplanets are detected indirectly, usually through the dimming of starlight during a transit. But Webb's capabilities allow scientists to see planets directly and analyze their atmospheres, structure, and chemical makeup. That brings us to WASP 39b, a Saturn-sized exoplanet located about 700 light-years away, in the Virgo constellation. Orbiting its star at just 1/8 the distance Mercury is from our Sun, this planet endures extreme temperatures. Webb's spectrographs were able to break down the starlight passing through its atmosphere, revealing carbon dioxide, sulfur dioxide, and silicate clouds. The first time some of these compounds have ever been detected in an exoplanet atmosphere. Nye highlights how this kind of analysis brings us closer to answering the ultimate question: are we alone? If we can detect chemicals associated with life, like oxygen, water vapor, or methane, on rocky planets in the habitable zones of distant stars, we might one day confirm the presence of life elsewhere in the cosmos. Webb also turned its gaze toward galaxies closer to home, such as M74, nicknamed the Ghost Galaxy. Though faint invisible light, it shines brilliantly in infrared. Webb's observations revealed filament-like structures of heated dust and gas, spiraling out from the galactic core. These filaments outline regions where new stars are forming. To fully explore this galaxy, scientists combined data from Webb and Hubble into a stunning composite image, developed through the PHANGS project, a collaboration involving NASA, ESA, and several ground-based telescopes. Another mind-bending discovery came from Webb's observation of Wolf Rayet 140, a dying massive star surrounded by peculiar concentric dust rings. These aren't visual artifacts, they're real structures produced by interactions between WR140 and a companion star. The rings are made of stellar material ejected in rhythmic pulses, forming a beautiful yet eerie spiral shell. These dying stars shed mass at an incredible rate, setting the stage for future supernovae. Webb is helping scientists understand the final stages of massive stellar life cycles like never before. But perhaps the most jaw-dropping announcement came in December 2022, when researchers revealed Webb's detection of 4 of the oldest known galaxies, dating back 13.4 billion years. Just 350 million years after the Big Bang. These galaxies were discovered as part of the JADES, JWST Advanced Deep Extragalactic Survey, project and confirmed using near-infrared spectrography to measure redshift. The highest redshift recorded was 13.2, placing these galaxies at the edge of the observable universe. Bill Nye emphasizes the importance of this moment. For the first time, we can not only detect these remote galaxies but also verify their distance and age, confirming that they formed very shortly after the universe began. This is more than a technical achievement, it's a philosophical one. It means we can study the early universe in detail, understand how galaxies emerged, and possibly even track the conditions that gave rise to life as we know it. As JWST continues its mission, scientists will use its unparalleled sensitivity to explore supermassive black holes, galactic collisions, the chemical evolution of stars, and the structure of the early universe. Each image and spectrum it sends back is a puzzle piece in the story of everything. Bill Nye reminds us that space exploration is not just about looking outward, it's about looking inward as well. These discoveries challenge our place in the universe, confront us with our own impermanence, and yet fill us with hope and wonder. As galaxies form, stars are born, and light from the ancient past reaches us today, we are witnessing the cosmic story unfold in real time. So, what do you think? Has the James Webb Telescope changed the way you see the universe? Let us know your thoughts in the comments below. And if you enjoyed this journey through time and space, don't forget to like this video, subscribe to Discovery 2.0, and share it with others who are curious about the cosmos. Together, we'll continue unraveling the mysteries of the universe, one discovery at a time.